Here's why Google wants to put AI data centers in space. They just announced Project Suncatcher, which is a new initiative to build data centers in orbit powered entirely by sunlight. One of the biggest challenges in AI right now is energy. AI models are getting so massive, but so is their energy footprint and strain on the grid. So if energy is the constraint here, why not move compute to where energy is unlimited? In orbit, solar panels are up to 8 times more productive than on Earth. And since there's no atmosphere, there's also no energy loss, and you can get near constant sunlight. So that means 24/7 power, no night cycles or weather interruptions. In their proposed plan, each satellite would carry its own TPUs, which are the same chips that power Gemini and other AI models. Instead of connecting them through fiber cables, these satellites would form what's essentially a floating data center cluster in space. They'd orbit about 650 kilometers above Earth and fly in these tight formations hundreds of meters apart, which is super close compared to Starlink satellites that are spaced about 120 kilometers apart. They plan to connect these satellites through these free space optical links, which essentially laser beam data between them. However, it's worth noting that there are 3 big engineering hurdles to all of this. One is radiation. Cosmic radiation from space literally fries electronics. However, Google tested its Trillium TPUs in a 67 million electric volt proton beam, which is the same kind used to simulate cosmic radiation. And the chips actually survived 3 times the expected 5-year radiation dose, meaning that there weren't any permanent hardware failures. The second big issue is formation control. Since they'll have hundreds of satellites floating around just a few hundred meters apart at 17,000 miles per hour, they're going to have to figure out advanced orbital dynamics modeling, aka a machine learning based flight control system that can handle microcorrections in real time. And finally, the third challenge is cost. Historically, launching anything to orbit costs around $10,000 per kilogram. SpaceX's reusable rockets have actually brought that down to around $3,600, and projections show that it could hit $200 per kilogram by the mid-2030s. At that point, the cost of launching and operating a space-based data center could pretty much match the energy costs of running one on Earth. Obviously, building in space sounds expensive, but electricity on Earth isn't cheap either. And if you can build an orbital system that runs entirely on sunlight, you could argue that the marginal cost of energy approaches zero. Environmentally, it's also super appealing because there's unlimited sunlight, no cooling water needed, no carbon footprint, and compute that essentially scales as far as the sun shines. This is all still super early and experimental, but it could change the economics of AI infrastructure if it works.